Fuel filters. The fuel must be absolutely clean before it enters the fuel injection pump and the injectors. The smallest of particles can damage components in the fuel injection pump and the injectors, which will result in immediate breakdown of these two components or more long-term damage of the inner parts of these components. This will lead to a faulty dosage of fuel to the engine. This will also cause poor combustion, which will cause performance loss, increase of emissions and disturbance in the engine, resulting in higher noise. Also, when the fuel passes through the filters, the water is removed to prevent any corrosion of the fuel injection inner parts, which would also result in permanent damage of the system. Consequently, the fuel must pass through two fuel filters before it reaches the fuel injection pump and injectors. These filters contain pleated paper cartridges. The filter cartridge and filter canister are integral and are called spin-on or box filters. We're going to take a look at the Renault fuel filters. We've taken the filters and cut them in half so we can see inside. One of the first things we notice is these springs at the top. These springs are very important. They hold the canister down and apply pressure to this seal at the bottom of the filter. This is important because as the pressure builds up in the filter and as the vehicle goes over bumps as it's driving along, the canister can move. So we need a good solid spring at the top to prevent The non-genuine filters tend to use a metal strip instead of any glue. This metal strip looks solid, but what we find is that because the filter media is pushing against the edge of the metal, it can split the filter media along the length of the strip. This is why Renault used the glue method to give a better surface area for the join. We have measured the thickness of the metal casing. This is important because as the filter is in operation, sometimes you can get a filter blow. This is where you get a weak point and it explodes the filter as the pressure builds up. We have measured these and the thinnest point on the Renault Genuine is 0.63 mm. The non-genuine is 0.51 mm, which means that at its thinnest point it is 19% thinner than the genuine. This means that as pressure builds up inside the filter, the Renault Genuine is a much stronger casing. We have removed the filter heads and we can see on the Renault Genuine compared to the non-genuine is the holes are in a different place. This is because when the filter is installed in the engine, these holes match up to the holes in the filter head. The non-genuine is designed to fit a number of vehicles, so these holes are in the wrong place for use on a Renault truck. These holes won't match up when installed on the engine. This will affect the flow going through the filter. We also know that this rubber ring in the Renault Genuine is a nitrile rubber that meets the heat requirements of a Euro 6 engine. We don't know if the non-genuine ring is capable of dealing with the heat of the Euro 6 engine. Therefore, it is important that we use the correct rubber ring. Oil filters. One of the tasks of the lubricating oil is to wash away impurities from the engine's lubricating points and bearing surfaces. The oil then becomes dirty and must be cleaned before returning to the lubricating points again. The oil is coarsely strained when it passes through the strainer in the sump. Oil is pumped from the oil pump to the filters. Here it is filtered by two full-flow or long-life filters. These filters take the majority of the oil and filter it to around 30 microns. Depending on the engine, we can have a third filter. This is called the bypass filter. Around 10% of the oil flow is skimmed from the main oil flow and sent through this filter, where it is filtered to about 10 microns. This means that around 10% of the engine's oil is being filtered to this extent on a constant basis. There is one important item on the engine that needs to take its oil supply from this bypass oil line, the turbo. It is important that the turbo gets its oil from this line, as the heat produced, speed it operates at, and the tolerance a turbo is manufactured to means it needs this level of oil filtration. Therefore, it is so important that we have the correct bypass filter fitted to the engine, as we know the genuine filter has the correct level of filtration to protect the turbo. The oil filters consist of replaceable filter cartridges containing inserts made of pleated filter media. All the oil coming from the pump passes through the filters to be cleaned before entering the engine again. So now we're going to have a look at the Renault oil filter. This is the long-life oil filter. Like with the fuel filters, we have cut the filters in half so we can see inside. As we saw with the fuel filters, the same things apply with the springs here. The Renault Genuine filter has this leaf spring design, which is very solid and doesn't allow for a lot of movement. This non-genuine has an even weaker spring than what we saw with the fuel filters. This means we get quite a lot of movement with the casing inside. This allows the cartridge to move around quite easily inside. Another thing we can see again is that this has the metal strip that joins the media together. The Renault Genuine has the glued strip here, which is a lot better for sealing. We have measured the casings like we did with the fuel filters, and we know that the Renault Genuine filter at its thinnest point is 0.69mm. The non-genuine is 0.59mm, 15% thinner. That means that the non-genuine is thinner at its thinnest point than the Renault Genuine, which is very important when in operation. We have also measured the amount of paper inside these cartridges. We've found that the Renault Genuine has more surface area of filter paper than the non-genuine. This is important because as the filter blocks up, we need more filter paper to get the flow going through the filter. The less paper we have, the lower lifespan of the filter, and the flow will become more restrictive. Surface area of the filter paper is very important. We have looked at the end caps. Again, we can see the holes are in different places. This could result in a restriction of flow going through the filter head.